Your microwave doesn't actually cook your food, it bullies it. Specifically, it targets water molecules and just shakes them, like a tiny invisible mosh pit in your leftovers. Here's the wild part. Water molecules are basically little magnets, so when microwaves hit them, they spin back and forth millions of times per second. And all that frantic wiggling? That turns into heat. So yeah, your soup isn't gently warmed. It's being aggressively jostled until it gives up and gets hot. Your microwave oven is basically a tiny physics experiment sitting on your counter. And it works by blasting your food with invisible waves of energy. Not heat. Waves. These are microwaves, a type of electromagnetic radiation, just like visible light or radio waves, except these are tuned to a very specific frequency that water molecules absolutely cannot ignore. Think of it like playing the exact note that makes a glass vibrate, except instead of glass, it's every drop of water in your food. When these waves pass through your leftovers, they don't heat everything evenly right away. They specifically target molecules that have an electric imbalance. And water, being a slightly lopsided molecule, is basically the perfect victim. So instead of heating from the outside in like an oven, microwaves dive straight into the food and start interacting with the stuff that can respond. Which means your microwave isn't cooking in the traditional sense. It's selectively energizing the parts of your food that are easiest to bully. Here's why water gets picked on so much. A single water molecule isn't symmetrical. It has a slightly positive side and a slightly negative side. That makes it polar, which is a fancy way of saying it behaves like a tiny magnet. Now imagine billions of these little magnets packed together inside your food. When a microwave's electric field flips direction millions of times per second, those molecules try to flip with it. Back and forth, non-stop. It's like forcing a crowd to instantly turn around every time someone snaps their fingers. No one's comfortable, no one's coordinated, and everything gets chaotic fast. That constant flipping is the core of microwave heating. The waves aren't hot themselves. They're just bossy. And the water molecules? They don't get a choice. So what happens when you force billions of tiny molecules to spin back and forth insanely fast? They start bumping into each other. A lot. And that's where the heat comes from. Not from the microwave itself, but from the chaos it creates. As water molecules twist and collide, they transfer energy through friction at a microscopic scale. It's like rubbing your hands together really fast. Except now imagine doing that with trillions of hands all at once. That energy builds up as thermal motion, which we experience as heat. So when your food gets hot, it's not because something is adding heat directly. It's because the molecules are being shaken so aggressively they start heating themselves. Honestly, it's less like cooking and more like molecular harassment. And eventually, the molecules give up by settling into higher energy motion, which just means your food is now hot. Now here's the part that explains why your leftovers come out weirdly inconsistent. Microwaves don't spread energy perfectly evenly inside the oven. They form patterns, hot spots, and cold spots depending on how the waves bounce around. On top of that, not all parts of your food have the same amount of water. So some regions get shaken like crazy, while others barely get touched. That's why you can have a plate where one bite is lava and the next is suspiciously cold. The spinning turntable helps average things out, but it's not perfect. You're still relying on waves bouncing around a metal box and hoping they distribute nicely. Which they don't always do. So uneven heating isn't a flaw in your leftovers. It's baked into the physics of how microwaves bully water molecules in the first place. And finally, why does metal freak out in a microwave? Because unlike water, metal doesn't absorb those waves, it reflects them. The electrons in metal are free to move, so when microwaves hit, they get pushed around rapidly instead of flipping like water molecules. That movement can concentrate electric charge in sharp edges or points. And when that charge builds up enough, zap, you get sparks. It's basically the microwave losing control of where its energy is going. Instead of gently shaking molecules, it's accidentally creating tiny lightning bolts. So while your food is inside getting relentlessly jostled into warmth, that forgotten fork is starting a completely different physics experiment. one that your microwave definitely did not sign up for.